I couldn't be more excited today to talk to you guys about how we at Cloud Posse have achieved unlimited staging environments on Kubernetes. That is, how we can run complete fat stacks of fully disposable apps on Kubernetes for staging and development, and really nothing is holding us back from doing that on production as well. So to give you guys an overview of what to expect today, it's going to be about 30 minutes of me talking. I'm going to start off with my background, why I'm so excited about our solution and what drove us to come up with this solution, the what, why, and how of unlimited environments with lots of screenshots so you'll get a clear picture of exactly what it looks like. Then we'll roll the dice and do a live demo so you can see it in action, that it actually works. At the end, we'll give you links to all the tools. They're all open source. They're mostly on our GitHub or other public GitHub repos out there. At the end, we'll follow it up with a Q&A or ask me anything, and I'll be happy to answer. All right, so I was the first director of cloud architecture for CBS Interactive, and I cut my teeth on sites like TV.com, Metacritic.com, and Clicker.com. After spending some time at CBS Interactive for a few years, I ended up taking an extended sabbatical. I traveled the world for a couple of years and then came back and founded Cloud Posse. Right now, I couldn't be more excited about the tools available. When I started using Amazon, this was in 2006. My first startup, we were a very young startup that got into an early private beta of AWS. And at that time, there were no tools available to us. We had to build everything from scratch. It's a very different situation today. So at Cloud Posse, what we're really focused on are cloud migration. So helping companies move from platforms like Heroku onto Amazon using technology like Kubernetes. We can't deliver that solution if we didn't also have complex CI/CD pipelines and really smooth automated deployment processes. So that's why when a customer came to us and basically asked us, how can we rapidly spin up new environments from scratch in a matter of minutes, triggered simply by the push of a button or automatically for every pull request, we got really intrigued. We spent probably 2-3 months working on this demo to get it working, and this is because we wanted a lot of features in this. We knew we had to be able to deploy absolutely any branch or combination of branches because today's microservices are pretty complex. We also needed to have it fully integrated with CI/CD. So what we're really saying is we want an unlimited number of CI/CD pipelines, basically one CI/CD pipeline per environment. We also needed to make sure that every app was directly accessible from the web. So something like feature-1234.demo.cloudposse.org. We also wanted it to not be relegated to a few specific individuals who are comfortable on the command line. We wanted it to be open to pretty much anyone with permission to deploy. That means designers, front-end developers, and back-end developers as well. So that's why we had this requirement of no console access required. We also needed it, of course, to be GitOps friendly, basically Git as the system of record. We wanted everything to be stored on our GitHub and all of our releases pinned to specific point releases, not pinned to latest, something very specific so we have stable environments. So this is why we think this solution is really intriguing. Obviously, we can use it for all the standard use cases like integration tests and generally awesome QA, but where it really shines is the ability to prototype new features. For example, imagine your company is going to have a hackathon this weekend and you need to have 10 different environments for 10 different teams. You want to spin those environments up really quickly, and you want those integrated to CI/CD so that they can push their changes quickly and share them with the rest. Similarly, perhaps you have an epic that you're working on that might take a couple weeks or a few weeks to complete. You're involving lots of different team members from the front-end developers, back-end developers, and designers. And they need to be able to push changes on a feature that you're working on without destabilizing perhaps your pre-production staging environment. So these are maybe features that can take weeks or months. So you still need a place to show them. Another very real use case in use today by one of our customers is the ability for sales teams to demo features. So in this case, it's an enterprise SaaS software. And what the sales team wants to do is spin up a complete environment and stage a certain data set on there so that the demo looks really good for that customer based on the market or demographic that they're in. So these are the ways that it really stands out. Our solution is not really that novel. It's using the standard pipeline that you're familiar with and the standard workflows. So we're using the standard Git workflow with branches and tags to keep code isolated. And currently, we only support GitHub since that's just where all of our customers are. Then we integrated that with the Codefresh CI/CD pipeline. We looked into using a lot of different other CI platforms, and internally we have competency on Circle CI, Travis CI, and Jenkins. But what really stood out to us about Codefresh in this case was its tight integration with all the tools that we needed, specifically Helm, Docker, and Kubernetes. So I'll tell you a little bit more about what those technologies are as we move along. So we have this pipeline now, and it's building Helm packages that are pinned at specific releases of Docker containers. Now, for the uninitiated, Helm is a package manager for Kubernetes. And if you're familiar with other package managers like NPM or apt for Debian and Ubuntu, or RPM for Red Hat and CentOS, Helm is like that, but it's really different when you think about it, because all these other package managers, they're concerned about deploying a single package or a single application on a single host. So when you install Apache, for example, it installs it on a single host. Well, Helm is a way to package architectures together into immutable artifacts that you can then store in a registry. That is, you can package the architecture for a cloud-native, scalable application as code. So then we have these containers. These are Docker containers I'm talking about, and those have been built and tagged with a semantic versioning scheme that we've come up with. And I'm going to show you more details of what that looks like shortly. I just got a poll here. So we have now these Helm packages, and they're pinned at containers. This is a very opinionated approach that we're taking at Cloud Posse, and why that is if you know how Helm works, Helm lets you really deploy any image or any container for a given Helm chart. Helm charts are what you call the packages. What we didn't like about that solution is that it's really difficult to figure out which Helm charts are compatible with which containers. So instead, we eliminate the calculus of that decision making and instead just pin them together as immutable artifacts that are stored in a registry, and there we have it. We don't, a few months from now, we won't know which packages are compatible with which containers. Then
so
now
Eric,
yeah.
Sorry, just to interrupt really quick. We ran that poll and it looked like about half the audience hasn't heard of Helm before. So maybe just to introduce Helm to the audience, Helm is and I think you did a great job, Helm is a package manager for microservices for Kubernetes. So if you're going to deploy WordPress, for instance, which has a PHP service, a MariaDB, you can actually create a Helm package that says, so you can basically say, I want to install the WordPress Helm package, and it will deploy all of those containers onto Kubernetes. So go ahead and take it away.
Exactly. So that's a really good use case that he brought up, deploying a package that many people are familiar with. So what we're doing is now taking our custom application, our proprietary application, and bundling this as a private package. And then we can deploy that package on Kubernetes, and it builds out the entire architecture with load balancers, EBS volumes, replica sets, and it sets up like the service discovery between them, so services can talk to each other by simply using DNS. And since we deploy this in a namespace in Kubernetes, that means we can keep all those resources totally isolated. We can set resource quotas on that namespace so that it doesn't take out the rest of the cluster if it uses too much memory or CPU. And then when we want to destroy that temporary namespace, we can just click delete, and all those resources are deleted. So namespaces are a native concept of Kubernetes. Another concept of Kubernetes are ingresses, which are basically the way to route traffic between services in your cluster. This is like layer 7 HTTP routing. So send this path and this host to this service. One of the cool things with Ingress on Kubernetes is you can actually have automatic DNS supported with that. So your service, when it gets deployed, can say, hey, I want to be associated with this DNS name, and now it's publicly accessible.